So it's time for a dad joke. I told him I was going to be introducing the speakers, so he said I should tell you, those are JBL Eons. Those are Cobras. I think I saw some Sennheisers in the back, and I call this one Annabelle, and that one's Fred. That'll be my last terrible joke. Probably not. So my allergies are acting up. I'm allergic to your fine city. So my voice is going to go down as the afternoon progresses, first through Kathleen Turner, then Cher, and by the end of the day, I will be in James Earl Jones. You're welcome. So I'd like to thank our gold sponsor, Index Data. A round of applause for Index Data. So one of the things that makes Code4Lib stand apart is that it is a diverse group of people with a welcoming environment. One such example is the 2018 Diversity Scholarships. These were awarded to members of groups not well represented within the Code4Lib community, including, but not limited to, women, people of color, people with disabilities, LGBTQ, with an interest in actively contributing to the missions and goals of the Code4Lib conference. The recipients were selected based upon strength of application and financial need, and they were provided with up to $1,500 to defray costs associated with attending the conference. The following organizations and individuals contributed to the scholarships: MIT Libraries, Duraspace, Smithsonian Libraries, The Ohio State University, Temple University Libraries, the school at Illinois' iSchool of Information Studies, and the Angel Fund, which is made from contributions from individual Code4Lib members. We would like to thank everyone who contributed to the Angel Fund this year. Matching funds were our new initiative to raise diversity scholarship funds and to double your donation's impact. Special thanks to the anonymous, generous individuals in the Code4Lib community who pledged to match funds once a matching fund goal was reached. This year, we're happy to share that LibTech Women matched 25 donations, and Mark, more assorted and representative community, matched 12 donations. Through these efforts, we were able to provide the largest total number of scholarships in Code4Lib history and fund 4 full scholarships from the Angel Fund alone. Go you! This year, the Code4Lib community and partners made it possible for us to offer more scholarships than ever before. We received a large number of applications from highly qualified candidates this year, and it was a humbling experience for the committee to select just 13 awardees. They are Nicola Andrews, Carly Bogan, Laura Chong, Yi Ding, Lev Earl, Crystal Falima, Tiffany Henry, Alyssa Loera, Dominique Luster, Sonoe Nakasone, Gina Norton-Smith, Maddie Schrader, and Jessica Wu. Congratulations. And we invite you to visit the scholarship page on the conference website to learn more about it. Our afternoon duty officers are Sean and Bethany. Can you wave, Sean and Bethany, in the back? It is flu season. The CDC says to wash your hands or use alcohol-based hand sanitizer often. Avoid touching your eyes, nose, and mouth. And cover your mouth and nose with a tissue when you cough or sneeze, and throw the tissue into the trash. Or do the vampire cough. If you have flu symptoms, stay at home until your fever is gone on its own for 24 hours. Since you can't stay home, you can stay in your room and stream the conference. It's a bad flu year, so let's not all get sick or become carriers. So now I would like to introduce the Group 2 presentations. They are 15 minutes each, so we're going to ask that we hold the questions till the end. And first up, I have Pi Call Number for Tricky Call Numbers by Jason Tamale.
Yeah, I didn't fall. All right. Hey, everybody. Hope you guys are doing good after lunch. Doing well, sorry. Okay. I'm here to talk to you guys about PyCallNumber, a Python module that I've written to help parse and normalize different types of call numbers. And I know you may be thinking one of two things. Either, oh God, 15 minutes about call numbers, or, oh God, Python? Well, yes and yes, which means I will be delving into some Python code, but we are a diverse group and with diverse knowledge and skills, so I'll try to walk that fine line between boring you and annoying you. Okay, let's talk about call numbers. We all know that they're a type of encoded alphanumeric string that we assign to each of the physical items within a collection, which helps us arrange those items so they're findable within a particular space. They're designed to help us identify items by making each one uniquely addressable in context of the whole collection when put into shelf order. Plus, most call number schemes are designed so that a call number serves in some way to classify an item based on one or more attributes, usually related to subject content. Now, stopping a moment to think about this from our perspective as Code4Libbers, having a small token for each holding that relates everything both in terms of space and content? Nice. Perfect for doing things like mapping collections, visualizing and analyzing collections, and building virtual shelf browse applications to aid discovery or inventory tasks. But when you consider the context surrounding call numbers, the fact that catalogers build them by hand and assign them to items, staff put the items in call number order on the shelf by hand, and patrons manually browse the stacks to locate items by call number, it's clear that call numbers are very manual, same as a lot of the other data that we have to deal with. So they're at the same time compact and information dense. They're simple on the surface, but this belies a deeper complexity. They're structured based on explicit rules, but there's always room to take liberties, as long as the result is still intuitive enough that people can browse and find things. Ultimately, this boils down to call numbers being mostly, but not entirely, machine readable, which a lot of us find really, really intriguing, despite or perhaps because of the fact that they're pretty tricky to work with. No matter what your end goal is, the primary task you have to be able to accomplish with call numbers is sorting them in shelf order. So take this short list of LC call numbers, for example. Let's pretend that we're at the Python console, and just in case this is new to you, this is how we can enter and run code interactively and get immediate feedback. The angled brackets at the beginning are a prompt for the first line of a Python statement, which you can continue on subsequent lines if needed, where the prompt changes to 3 dots for each additional line. When you finish your statement, it executes it for you and gives you output for whatever it returns, if anything, and then it gives you a prompt to start a new statement. Here we're assigning each of our call number strings examples to the variable callnums as a Python list. A list is equivalent to what most other languages call an array, an ordered list of elements, and it stores these in the order that I've assigned them. So to sort them, the first thing that we'd probably do is just try passing the callnums list through Python's built-in sorted function. This takes a list and returns a new list with the elements put into sort order, ascending order by default. Running this returns this list. Still not quite correct, is it? The problem here is this last call number. 90 is less than 100, so MT90 should go before the MT100s. It sorts this way because 90 isn't less than 100 when you're comparing the two numbers lexically as strings. It's the same as comparing words alphabetically. Words starting with B don't sort before words starting with A, regardless of word length. But we can force our numbers to compare correctly by left padding the shorter number with zeros. This way it compares the hundreds to hundreds, tens to tens, and so on. So if we make that change to our columns list and then sort again, we see that it worked. Pretty simple, right? Conceptually, that's about all there is to it. It's pretty much just a matter of creating normalized versions of your call numbers that you can use as keys to compare against each other. But this is often much easier said than done due to a few complicating factors. For instance, we just talked about using zero padding here because 90 is less than 100, but by that same logic, 5 is less than 35, so shouldn't we add padding here so that these sort like this? Totally reasonable and yet totally wrong. With LC call numbers, the part immediately following the classification number is the cutter, and you're supposed to treat the numeric portion like a decimal, not a whole number. But to know that, you have to know how LC call numbers work. Similarly, here, padding MT90 with just 1 0 works in this case because the other call numbers we're comparing it to only have 3 digits in their classification numbers. but LC class numbers are generally valid up to 4 digits. So knowing that, we can assume that we should actually pad each of the LC class numbers to at least 4 digits for a more universal solution. So at first and even second glance, it's tempting to think maybe you could normalize any call number set just doing a few simple general operations. But in reality, the best normalization for any given string depends on what type of call number it is. LC, sudox, DOI, etc. each has its own rules and structure. So the first step is to parse each call number so that you can figure out its structure, which is trivial if you have pristine data. But what if it's more like this? Well, still not awful. I mean, at least you can identify these as LC call numbers, right? You could just normalize case, spacing, and punctuation to clean it up. Certainly doable. But wait. What if you're not sure that the set you're working with contains only LC call numbers? What if you could have local call number formats and other non-standard or localized data thrown into the mix? I won't do the primal scream for you. And bear in mind that you have to be able to get your data to the point where you can compare each call number character by character to put them in the correct order. So, messy data is frustrating, but it's never completely random. Cleaning it up usually involves trying to find some underlying patterns, and so regular expressions are, of course, the natural tool of choice. With these, we define common patterns to match against our call number strings to use as a basis for parsing and normalizing. But the more variation you have to account for, the more patterns you have. The more patterns you have, the more complex your regular expressions become. Powerful as they are, they quickly get very complex and hard to read. And the more complex they become, the more brittle they tend to be, and the more difficult they are to test and maintain. So when you're handcrafting and hard-coding regular expressions, the end product typically turns out to be a tool that's been highly tuned to one task, situation, part of your collection, or type of call number. And then the next time you have to do something similar but different, you end up having to build something new from the ground up because your data no longer fits. Indeed, tools for handling call numbers already abound in the Code4Lib community, and questions about handling call numbers keep coming up time and again. So what makes call number any different? And I'm sure we've all seen that before, possibly. Well, I didn't actually write it to be a universal solution. I just wanted a more general solution. I've worked on a few projects now pulling large sets of call numbers straight from the catalog where the data is messy. I can't really trust what the mark says the call numbers are, and I can't just ignore ones that don't match the supposed pattern. I found that tailoring an existing tool would require enough of my own code that I may as well just write something from scratch. But doing that, even my own code has turned out to be less reusable than I'd like. Eventually, I realized I could generalize much of that code, and PyCallNumber was born. So what does it do? Well, once it's installed, you of course have to import the base PyCallNumber module to start using it. And since PyCallNumber is kind of a long name, here I'm aliasing it as CN, which lets me invoke the module's API using the shorter name. Then you can pass a call number string to the cn.callNumber function to convert it to a call number object you can work with. The output here shows the string representation of that object, which tells you that it's an LC type call number. As long as your original call number string matches one of the call number types that this function knows about, you can use it to identify something and convert it to an object of the corresponding type. By default, in addition to LC, it recognizes both sudox and DOI. If your call number string doesn't match one of these, then it still tries to parse it intelligently as a local format, which is just a generic catch-all for anything not matching a more specific pattern. So once you've created your call number object, what do you do with it? Well, when you initialize an object, your call number string is automatically parsed, giving you access to its individual parts via object attributes. For example, this is an LC call number. As such, we can access its classification number, its cutters, both as a group and individually, and also optional addition and item information. Plus, every call number and every part of every call number inherit from the same base class, so they all share certain behavior. You can access parts of parts like classification letters and numbers, and parts of parts, such as the whole number and decimal portions of the classification number, and so on, until you hit the simplest, most atomic parts. Of course, each different type of call number has different parts with different names, so you have to check the object's part names attribute to find out what those are. Now, one thing you might have noticed here is that this call number string we're parsing was already formatted pretty cleanly, and one of the complicating factors that I talked about earlier that makes parsing call numbers difficult is the fact that call number data can be so messy. If we tried generating a list of call number objects based on this list of variously formatted call number strings and store it in the variable messy, we see, first of all, that they are correctly parsed as LC call numbers. Secondly, even though here they each appear to retain their original string representation, if we actually compare them, they're all equal to each other. And this works because PyCallNumber normalizes call numbers for you. You can access the canonical normalization for a call number via its forSort method, which is automatically used as the key for object comparisons. This shows that we've called the forSort method on each call number in messy, and each one normalizes to the same canonical sort string. If you still need the original string, by default you can get it by calling forPrint, or simply printing an object directly. What if you wanted to normalize a set of call numbers a particular way for storage or display, for instance, to make them look pretty? Well, in my own local Python script, I might define a class called prettyLC. If I create this as a subclass of the main LC type, then my new class inherits all of the parent class's behavior unless I specifically override it. I'd only need to write code for what I want to customize, which is the forPrint method. Since each call number is parsed on initialization, an object's methods can access its own parts by name, letting me build my own normalized format cleanly in sort of a declarative way. And that brings me to the topic of customization. Earlier I said existing tools and techniques for handling call numbers tend to be too specific and brittle, and they end up not really translating well to different contexts. What I've shown you so far may even leave you feeling a little underwhelmed. At the end of the day, we're still just matching data to patterns, and all I've really done here is create a bunch of really elaborate patterns with defaults based on data from my institution. What if your data is different? For example, the built-in DOI class assumes your DOI call numbers start with a DOI class number, but it's not that uncommon to use a locally defined prefix denoting a particular location or collection. So let's say your institution uses a prefix with a 2-letter shelf location code and a shelf number 1 to 100. How might you create your own custom DOI type and then use that with the call number function to recognize your local DOI format? Well, call number classes are and are composed of units. Simple units are the most granular, things like LC class letters and even individual characters. In fact, every call number can be broken down into component strings of these 3 types: alphabetic, numeric, and formatting. They're what provide most of the underlying sort normalization algorithms. Compound units, then, are just units that are composed of other units: LC classes, cutters, DOI classes, full call numbers, even things like representations of dates and formatted numbers. PyCallNumber defines dozens of unit types for you, which are all available to you through the API, and they're designed to be modular and extensible, so you can import the built-in types into your code to help you customize them or construct your own. So for our custom DOI type, first we'd create our own unit class to represent our local DOI shelf prefix. Next, we'd add a template attribute so that we can define the necessary structure. Earlier, we said we needed a shelf location followed by a shelf number. Each template group configures each part. It defines what that part is named and what type of unit it should be. Optionally, you can also specify how often a particular group occurs, that a group can be one of multiple types of units, or that a unit serves as a separator between 2 main groups. These options give you some flexibility in how you create your templates. But in the interest of space, here I'm keeping it simple. Now, these 2 unit types aren't defined yet, so the next step is to create them. One thing you might notice here is that since unit classes are often composed of other unit classes, all of this tends to beget a lot of classes. So every unit class has a derive method that lets you quickly and succinctly derive a new subclass of an existing unit type. Now we just define our custom DOI class, putting a new template group for our shelf unit type here in front of the built-in classes list of template groups. And that's pretty much it. So let's see how our new class actually behaves. Say that we've saved all the code that we just wrote to a Python script in the current directory on our file system, and we've called that script localcn.py. So we'd import our myDOI class like this, and then we could instantiate myDOI objects 2 ways. 1, we could just do it directly like you do with any other kind of object, or 2, if we wanted to be able to use the myDOI type with the call number factory function, we could create a custom list of all the unit types that we want that function to be able to detect using myDOI in place of the default DOI type. Then if we pass that custom unit type list to the call number function via a unit types parameter, it overrides the default types and uses the ones we've specified. And if we examine the resulting object, we see our customized DOI call number in action. And there are a few additional things that you can do with PyCallNumber that I don't have time to cover, like working with call number ranges and sets of call number ranges. But once you can parse, normalize, and sort call numbers, creating and working with call number ranges is pretty straightforward. And PyCallNumber is, of course, up on GitHub under the UNT Libraries account. If you're interested, the README there has a more complete list of examples of how it can be used, including how to use ranges and range sets. So, thank you guys for listening.
All right, next up, we have One Step at a Time, Laying the Groundwork for Linked Data with URIs by Sonoe Nakasone and Don Pierce.
Hi, my name is Sonoya Nakasone, and I'm from North Carolina State University Libraries. And also, I just want to thank the Scholarship Committee for giving me money so I can be here. Thank you. So before I get into the presentation, I just want to do a couple of shout outs. The first to my co-presenter, Dawn Pierce, who couldn't join me today. Dawn is a terribly talented IT support specialist at our library, and she did all of the work on the Cersei API portion that I'm going to talk about a little bit later. So if you have any questions about that, please give her, please shoot her an email. And then also a shout out to the teammates that worked with us on this project. So this presentation is going to talk about putting URIs into MARC records in the subfield 0 of the 1XX, 6XX, and 7XX fields. And to talk a little bit about why we want to do this, to put URIs of MARC records, I just want to briefly review the concepts of linked data. So linked data is the idea of structuring data in a way that allows linkages to form between data across systems and for machines to actually understand these relationships. And here are the 4 principles that many of you are already familiar with. One is that you would use something called URIs as the names of things. 2, that those URIs would be HTTP URIs so that you can look up those names. 3, that when you look up those URIs, that you'd be provided with useful information. And 4, that among the useful information, or with the useful information, would be links to other URIs so you could continue to find more information and more things. In all 4 of these principles, you'll notice that URIs are a component. So URIs are actually a pretty important part of linked data. And if you're not familiar with what URIs are, they are uniform resource identifiers. So here's an example. Just by looking at this URI, you wouldn't necessarily be able to tell that it represents Maya Angelou. But if you were to look up the URI, you'd find out Maya Angelou's name, that she was a poet and an author, and even who her influences were. And if you look at the influence by Charles Dickens, even though you can't see it behind the scenes, there's a URI that links you to more information about Charles Dickens. So this one URI actually links you to a lot of information, and it keeps linking you to more and more information. The utility of URIs is so great that it's no wonder the PCC, the Program for Cooperative Cataloging, formed a URI task group to experiment with adding URIs to MARC records to prepare our catalogs to be transformed into linked data. And I just wanted to highlight George Washington University in particular, because their project to add over 4 million URIs to their production catalog is an amazing project and is at a much larger scale than what we did at NCSU libraries. So the goals of our project were to investigate 2 methods of inserting URIs into MARC records. One was using MARC Edit, and the other was using Cersei API tools. Our second goal was to educate the department on URIs and linked data. Technical services departments across the country are, they know that eventually they're going to have to transform their catalogs into linked data. And so we wanted to get ahead of this a little bit so that we were starting to understand these technologies and these principles. So we wanted to take something that was tangible and something that was easier to understand for us, like URIs, and link it to something that we were already familiar with, like MARC records and catalog data. So our third goal was to create a test set of MARC records that were enhanced with URIs, so that we can do further experimentation and learn more. Oops. So goal 1 of the investigation, I'm not going to talk about the method for using MARC Edit to add URIs to MARC records because there's already a lot out there about it. Jackie Shia from George Washington University Libraries and Terry Reese, the inventor of MARC Edit, wrote a paper on this, and then Terry Reese also has a YouTube video that shows you exactly how to use MARC Edit to add URIs into MARC records. So please check those out if you want to learn more about how to use this tool. I will spend some time talking about the method for using the Circe API tools to get URIs into MARC records. So this is the work that Don did. I'm going to use personal name authority as an example. So in a sample record for the book Life Doesn't Frighten Me, Maya Angelou is listed as the author in the 100 field, and Jean-Michel Basquiat and Sarah Jane Boyers are listed as contributors in 2 700 fields. These names would ideally be linked to an authority record in our catalog. So here's the book's bibliographic record, and highlighted in blue are those names of the authors and contributors, and we're starting out with no URIs in the subfield 0. So these are the requirements for getting the authority data into the bibliographic record. And these are the tools that are necessary for importing the authority data into a format that can be re-ingested. Except for the text editor processes, these are confidential tools, and they can only be used by API-trained Circe Dynix customers. So that's why we're not going to show any actual scripts or code today. Sorry. So the names for Angelou, Basquiat, and Boyers theoretically would link to an authority record by the authority key in the equals subfield if they're validated properly. This subfield doesn't display to users and can only be extracted by API. The unauthorized headings are in the question mark subfield and don't have an authority key. These unauthorized keys are excluded from enhancements because we might not have linking authority records, or other issues might prevent proper linking. The authority key in the bibliographic record for the book links to an authority record, like the one shown here. Highlighted in blue is the LCCN identifier for Maya Angelou in the 010. And here's a similar example for Basquiat. Using awk for text processing, Don generated the HTTP URI string using the LCCN in the 010 to output the string that's shown here. And in this first field is the authority key to generate this full string. So in this merged file, the subfield 0 string is appended to the corresponding bib tags based on the authority key. And here in the 1003 field is the key for the bibliographic record. The merge tool is great for recreating new tags, but it's not so great for matching and overlaying existing tags. Since incoming tags won't match existing tags, entries must be deleted and recreated, and the API tag delete option applies globally to the bib record, and even unchanged tags like the entry for Sarah Jane Boyers have to be recreated. So here's what the result looks like with the URI in the subfield 0. The result of our investigation was that we decided we weren't going to use either method to enhance the catalog, at least not to do a full-scale enhancement of the catalog with URIs. And the reason for that is because we wanted to first do more investigating on what we would do with our ephemeral records that we receive twice a month and often get overlaid. We just kind of want to have a grasp on that first. And then also, we did this project about a year ago, and we figured that by the time that we were ready to do this, there would be some vendor options that we might look at instead. So the outcomes of that investigation are that we created a test set of MARC records with URIs, and we generated new questions and new ideas for more projects. So the second goal of education, the method for that involved including the entire acquisitions and discovery department, of which I'm a member. So what we did was we had a workshop. We had laptops that we set up for each person and had software downloaded on those laptops. We had snacks. We kept it very informal and casual, or as informal as we could. We did a 15-minute introduction that talked about what we were going to do, how we were going to do it, and why we were going to do it. And that really set the stage to make sure that people understood that we weren't just providing this training for no reason, and that this was really a part of their evolution in technical services, and to help them understand more about these new technologies. We did a workshop that was a combination of demos and hands-on, so we demonstrated the process of exporting records from the ILS, and then the hands-on portion was them working with MarcEdit. And then as homework, we provided instructions for how to upload the records into the production catalog, which was something that most people didn't have experience with. So the outcomes for this, besides the test set of records that we have in our production catalog, is that it was well received by the staff. People felt like they had a better understanding of what URIs were and the utility of them in relation to linked data. And they also generated more interest. It also generated more interest in learning about MarcEdit. My two regrets about this project are that, one, we didn't actually do a survey evaluation, so we missed that opportunity for immediate feedback. And the other regret is that we did this too far ahead of other projects that could have built on the concepts and this experience that people had. People were just so jazzed and motivated, and there was a lot of momentum, and they were like, yeah, what's next? We're excited. But the project was about a year ago, and we haven't done a project to follow up on this. So I would do that differently next time. So in the future, we want to investigate vendor options like Marchive. We want to really understand what we would do with our ephemeral records, like those that we receive from Zero Solutions or other vendors. And we also want to do those projects to build on the concepts and the test set that we created. So do projects like take the MARC records that have URIs and transform them into BibFrame, transform them into schema.org, just kind of work with that process where we take our data and we get closer and closer to linked data and understanding those technologies. So thank you very much for your time and attention. Again, if you have questions about the CIRCE API portion, please email Dawn. And if you have general questions, please feel free to email me. Thank you.
All right, next up, APIs at the core, how Folio wants to engage you in creating new library services with Peter Murray. Yeah, we're kind of being inconsistent with clapping. I think we should all do it both before and after.
I'm also doing double duty as working on the live stream. For those of you listening on the live stream, we had a bit of a rough morning. We think our gear is okay. We think it's somewhere in the hotel or beyond the hotel to YouTube. Hopefully we got that worked out. Unless the live stream is down, in which case you'll catch this on the recording when I upload it. So about 2 years ago, Sebastian Hammer came to Code4Lib and talked about decomposing the integrated library system into microservice modules. And I was in the audience listening to this presentation and thought, wow, that sounds interesting. I wonder if that will go anywhere. 3 months later, Index Data hired me as the community assistant, the community organizer for what has become the Folio Project. 2 years ago, we didn't even have a name for it, but has become the Folio Project. Just to reiterate what Folio is about, first and foremost, it's about creating community where libraries can come together and talk about ways that they want to innovate services for their patrons. Second, to leverage open source software to reduce the costs. Of course, everybody in this room knows that open source software isn't free. It's, free isn't a free kitten. Here's your free kitten. Now you have to pay the vet bills and clean the litter box and so forth. But at least with this type of open source software, you're not paying any licensing costs, and you have the ability to adapt it if you need to. Third goal was to improve what it is that we're building by including librarians and subject matter experts in the process of building the software, to build it with a user experience design first philosophy. And we've done that. We've got about a dozen special interest groups now, about 150 subject matter experts that are working with user experience designers to create sketches and then mock-ups and then prototypes for the software that we're building. And then finally, to bring more choice in libraries. And this goal in particular drove why we chose to build this as a platform. So if you take those 4 goals, the technical approach that we chose is this decentralized, highly modular approach. Something that is a platform of services, something that you might think is akin to your iPhone that has apps on it from various third-party providers. And these apps communicate with each other and the underlying data stores, such as contacts data and calendar data and so forth. So from out of these goals and that technical approach, we have these characteristics. First, we have a platform that's extensible from the ground up. Everything in Folio is a RESTful API. Configuring your first tenant on the system is a RESTful API call. Instantiating a module is an API call. Setting permissions is an API call. RESTful APIs all the way down. Second, we wanted to be inspired by microservices. We wanted the ability for developers to create applications for Folio in whatever programming language that they wanted to, and to do that in such a way that you've got one program with its own data, making its own decisions about data storage, making its own decisions about URIs and entities that can interface with everything else on the system. Third technical characteristic is that it's cloud ready. We build on top of AWS. We don't use anything that's specific to AWS. Folio is on the back end built up of Docker containers, and on the front end is using a progressive web app based on React. I'll get into that in just a moment. If we were to put this in a diagram format, it looks something like this. In the upper right side is what's running in the web browser. And in the web browser, we've built a toolkit called Stripes, which is built on React and Redux from Facebook. And Stripes helps give a common look and feel to all of the apps on the Folio platform. It also helps manage the data, the caching, the updating that's happening in the browser, relieving the developer from having to worry about these things. In the middle is an Okapi Gateway. This is where all of the API endpoints live. Everything passes through the Okapi Gateway. Below it are a set of business logic modules in green, and a set of storage layer modules in whatever color that is, maybe orange. Of course, we're talking about RESTful APIs, and we've got these APIs that exist not only at the business logic and the storage layer modules, but they're also at the Okapi Gateway level. So if the browser, the user operating the browser wants to do a checkout, using the UI checkout module, they have to make a call into the mod user's storage module. That call goes through the Okapi Gateway. The Okapi Gateway is checking permissions. It's also a place where we're doing performance, instrumentation, data logging, and so forth. So it might have to do a get to users, do a get from item storage, and then ultimately make a post, HTTP post, to the circulation loans endpoint flowing through the Okapi Gateway to the mod circulation business logic module. So this is how the browser Stripes communicates with the underlying modules on the server. The servers themselves also go through the Okapi Gateway. So in this case, mod circulation needs to get information from the users module, so it calls the same users endpoint on the Okapi Gateway that the UI checkout module did in Stripes. Gets down to the storage layer. Also gets data about the item. And finally, it too needs to post information about this transaction to the mod circulation storage layer. So mod circulation posts to Okapi Gateway. Okapi Gateway then checks permissions, checks the proper tenant configuration, and proxies that request down to the mod circulation storage. So this is how the front end is communicating with the back end, how the back end is communicating with itself. You can think of this as an easy thing to replicate. If you had an NSIP responder that you wanted to build, you've got those requests coming in to NSIP. NSIP is going to use the same /users endpoint and the same /items storage items endpoint as the Stripes module did and as the mod circulation module did. Again, it's APIs all the way down. So thinking about things that are extensible in your library, you can create these things on top that are calling into the Okapi Gateway, into the underlying business logic and storage layers. You can also think about replacing things like maybe at the storage layer level. Mod login is on here, and it's talking to a database for username and password storage. We have a development team that is working on replacing that mod login with one that talks shibboleth out the other end to enable single sign-on. And as long as the shibboleth version honors the same API as that mod login does, it can replace mod login, and everything above it that is making use of mod login doesn't know that something has changed. So a few slides that talk a little bit more in depth than I went on there. First, the Okapi layer. Think of it as middleware, but those of you that are as old as I am might remember middleware meaning something else. This is really the switchboard, the thing at the core. It's inspired by the API Gateway microservices pattern. It's responsible for deploying and monitoring modules, service discovery. It also does request management, caching, request shaping, or what am I trying to say? Load balancing. And it also does hard permission checks. Is the user making the request really allowed to do what they're going to do? It makes that determination before it even bothers to contact the business logic module or the storage layer module. Okapi itself is multi-tenant. If you send a request to Okapi and you don't give it a tenant, it's considered an error. So you can have these modules running and being used by multiple tenants. Each tenant has its own data store and its own configuration. Some details about the gateway. We're using Vertex and using HTTP with all of its semantics. RESTful style calls, as you've seen. We prefer JSON as a message interchange format, but there's nothing that says it has to be JSON. And we support request and response processing pipelines. For an example, there's an auth module that gets called that does that hard permissions check at the Okapi layer. And so that's the first thing in a pipeline before any business logic or any storage layer modules are called. Vertex also supports an event bus. We think we might make use of it, but we haven't enabled it yet. The Okapi Gateway, as I said, it's RESTful all the way down for registering, deploying, and managing modules and tenants. We use this notion of pluggable HTTP interfaces. The dependencies are on the interface. The interface is stored in GitHub as a RAML file and as a JSON schema, and it's versioned. So if you're building a system, you've got to have all of the right versions. If you have an implementation that does something different from another implementation in terms of an interface, that's actually considered an error to be fixed. The Okapi modules themselves, self-contained HTTP services. If you've written HTTP microservices before, this is just the same thing. You have the freedom of choosing programming languages, development environments, underlying database stores, and so forth. There are a few things that Okapi insists on to handle lifecycle management. How do you start a tenant? How do you start a module for a tenant? How do you tear down a module for a tenant, and so forth? The Okapi Gateway is that switchboard insists on all of those implementations. And finally, the modules that you implement have to be stateless. This allows for easy load balancing and support for auto-scaling. So that's all this Okapi stuff is stuff that's running on the server. Running in the web browser is the toolkit called Stripes. And I underline a front end for this because you can have Okapi on the back end and on the front end have a mobile app or have something that's native to Windows or Mac OS. And making the same API calls to the Okapi as if you were Stripes running in a browser. But we are putting together a front end that we expect module users will want to use because we're providing a lot of work for you in doing so. But so there's a decoupling between the front-end modules and the Okapi modules, the front-end modules and the back-end modules, and there's this dynamic binding that makes sure that everything works well together. It's built on React and Redux. There's a leaky abstraction layer, so if you know React and you want to get down to the React layer, you can do that. And then we've got these other modules that help with user interface widgets and so forth. What we're building towards is that notion of an app store, the notion that you can bundle together the front end and the back end in an app store, and as the system administrator for a Folio system, be able to pick and choose which modules, which apps will work for you. And being able to enable them dynamically and have all of the interface checking happen to make sure that, the choices that you make will actually work. One final slide here as I'm getting yanked off the stage is a few URLs for you. First, the main website where you can sign up for our newsletter, the developers website, dev.folio.org. We have some vagrant boxes if you want to download them and just try out what the code looks like now, you can do that. If you're someone who's not a coder but wants to join a special interest group based on metadata or circulation or acquisitions, the list of our special interest groups are on our wiki. Thank you very much. I've lost the cursor. Oh, there it is.
Okay. So next up is low-cost preservation environment monitoring, I know how to speak English, with the Raspberry Pi by Monica Michelli.
Sorry for the long words of the title.
Okay. Just want to make sure everything's working.
Yeah, that should be it. All right. Hello, everyone. So As you know now, I'm Monica Michelli. I'm here from Pratt Institute in New York. I am assistant professor there, and I teach in the IT area for our LAS program. So I'm going to talk to you today about a project that I worked on in collaboration with one of our archives faculty members at Pratt. As you may know, if you're involved in archival work, controlling environmental conditions is obviously of utmost importance. Usually we endeavor to control those well through high-level activities like building and HVAC design. Those are harder to DIY, I will say. So one tool that is commonly used in conjunction with HVAC systems are data logger devices. They store and transmit data such as temperature and humidity, and there's a whole spectrum of different features that are available. In the course of some archival classes, we were purchasing different materials, including some commercial data loggers. You see an example here of the PEM2 from the Image Permanence Institute, and not to pick on them or this device in particular, but this was the one essentially that we used as a baseline, and we were interested in looking at building a microcontroller-based, essentially analogous device that could provide the same features that this particular device would for data logging capabilities. So this was my initial prototype of my data logger. You can see it's kind of rough looking. As you'll see, the reviewers had some comments about the form it takes, but I was most interested in function. So this data logger here is based on the newest Raspberry Pi, so the 3 Model B. It's running standard Raspbian operating system. And the main temperature sensing device there, which you see to the left of the box there, is the DH22 temperature humidity sensor. There's a whole series of these sensors. This is the high-end one, meaning it's under $5. And so that was combined with a few other features to essentially match what that previous data logger offered, which is obviously a screen that updates regularly data from temperature and humidity. The device also has a feature where if you are entirely networkless, you can simply plug a USB into the USB cable and it automatically copies over the data at that point. You can see this particular device was wired via Ethernet just because we happen to be in a conveniently wired building, but the newest versions of all the Raspberry Pi models now have Wi-Fi and Bluetooth built in. So this was the in-progress device. We also experimented with some additional sensors. You can see in the lower left there, that is a dust sensor, the Samyang DSM-501. There's been quite a bit of interest in environmental modeling, in starting to consider air quality and different dimensions like that. So we were interested in testing with the dust sensor. It ended up giving us kind of unreliable data and didn't play too well with the Raspberry Pi in general. So we ended up removing it from the final device, but I'll be working with it to experiment further in the future. So the Raspberry Pi provided a few features since it was networked. So essentially, using the Google Sheets API, the Pi would push data essentially at every 5-minute intervals, including temperature, humidity, and the particulate ratio. That's how the dust sensor essentially represents how particulated, I guess, the air around you is. In the left here, you can see a chart. This was actually when we were testing, and I was actually running it out of my apartment, so you can see that would be a really terrible archival environment. But it was kind of interesting to see, you know, I live in a typically sized New York apartment, so, you know, if someone takes a shower, everything kind of spikes with humidity and temperature. So that is not what where we are storing archival materials, fortunately. And you can see down at the bottom that yellow line represents the sort of oddly spiky data we were getting from the dust sensor, again, kind of pending further research. And down at the bottom, you see the email warning. So it was configured to essentially email a warning once a day when one of your thresholds had been exceeded, be it temperature or humidity, one direction or another. In these conditions, I was essentially getting warning emails every day, which is also a nice little reminder that the system's up and running happily. So we then took both devices, and they were used to concurrently monitor the environmental conditions. In Pratt, our main campus is in Manhattan, and we have several mixed-use storage rooms there where we hold various archival records. Most of the collection there is related to Pratt's history, particularly Pratt's history of the LAS program. So it was archival records from 19th and 20th century. So we placed both devices, endeavored to place them as close as possible to each other, so they were kind of occupying the same airspace there, and essentially left them alone for a 6-week period. We ended up gathering a total of just over 1,900 readings from each device. Again, each reading was time, date, temperature in Fahrenheit, and relative humidity percentages. And here you can see from the final results, we have here might be a little small here, but the blue line is the PEM2 and the red line is the Raspberry Pi. Temperature-wise, you can see we like to keep it a nice low 70s something in our building there. Also not ideal archival conditions. So this is just one sampling showing you a full 24-hour period. Second here, I have another, actually the same 24-hour period, instead looking at the relative humidity. You can see we have some differences there. The lower blue line is the PEM2, and the higher red line there was the Raspberry Pi. So as far as our findings overall, the PEM2, as I said, is just one of the many devices out there that Image Permanence Institute, as well as others, offer a whole series of devices, up into quite high features. This was honestly sort of a mid-level device. The PEM2 doesn't really provide any sort of network features, anything like that. In fact, one of its benefits is there's very low effort required in setup. You just kind of plop it somewhere and it goes about its business. And when you want data, you go and capture it off of it. So all that is about $430 or so. When it was all said and done, the Raspberry Pi that we constructed with essentially the exact functionality came in about under $100 or so. If you've done any work with microcontrollers, DIY in general, you know that the hours going into that probably added quite a bit more cost to that overall. During the 6 weeks, both devices performed generally reliably. There were actually a few reads that were missing from the PEM2 over time, and as this is sort of a black box device, there's really no way of knowing kind of what went wrong, and since the device does not have any network capability, the data is not essentially backed up anywhere or anywhere else, so if it's gone, it's gone. The Raspberry Pi did quite well. There were a few sensor readings missing from the Google spreadsheets. That API just seems to flake out occasionally and not record it, but we're talking about less than 5 reads over, as I said, about 1,900 or so. So you may have noticed from those charts that I had earlier, the mean of the temperature readings were not terribly different. They differed by about 1 degree Fahrenheit. I should mention that both of the sensors in both devices had essentially the same expected degree of error, so we wanted to make sure that we were using sensors that in theory could match the same level of data collection. So the mean of temperature readings was exactly what one might expect, since we had a plus or minus 1 degree of potential error with the temperature. When it came to relative humidity, that was quite different, as you may have noted from the charts there. We saw about a 6% difference in relative humidity. If we calculated in the total expected margin of error, it could possibly be up to 7% difference between the devices, so that is in between the margin of error. As our reviewer feedback suggested, and near the end, I will include the link to our paper that just came out in December of last year. The reviewers definitely had some concerns about the humidity reading and found that to be fairly problematic, particularly since these sensors don't come with the same essentially level of assured calibration and also recalibration over time that the commercial devices do. So with a device like the PEM2, that can be recalibrated essentially every 3 years or so. So the reviewer feedback definitely emphasized, well, you know, this has to be a device that can just be kind of plopped down in the wilds of whatever space we need to monitor, so it needs to essentially be independent of external power and networking. As I mentioned, issues with the humidity reading differences, and they also said generally it's an unattractive device, which I try not to take personally. I'm not good at the design side, so I'm calling it a prototype. But they had a good point, which is that it may be something that is integrated into, say, an actively used collection space, or say a museum exhibit, and you want it to be something that is not going to catch people's eye in a negative way. So that's all well and good, and that gave me a lot of ideas. So moving on to my current work here, if you've worked at all with a Raspberry Pi, you know if the requirements are, you know, low power consumption and ability to function well without network, you know, the Pi is not really the first choice for those sorts of use cases, largely because it is a small computer. So the overhead that comes with that, particularly power-wise, just doesn't really fit those requirements well. So I've moved on to assess a series of Arduino devices. You see the ones that I am currently working with on the screen now. And specifically, I'm looking at Arduino devices that can happily run battery-powered for months, if not even year or so. And by battery-powered, I mean those small coin cell batteries, so not something that is bulky. I'm also looking for devices that have some form of network connectivity. It came across pretty clearly that we can't assume wired or wireless internet access in these environments. So that led me to look at devices that have built-in Bluetooth, particularly Bluetooth Low Energy, BLE, as a useful way of allowing these devices to transmit data to one another or other devices and cover a larger space. So in the screen here on the left, you see the Adafruit Feather Bluefruit, and that also has a temperature and humidity sensor board. I tried to angle them so you couldn't see my terrible soldering on the side of that, so try to ignore that part. And then on the right is the RFduino, which is teeny tiny. All the pictures of it show it kind of sitting right on the tip of your finger. So these are both small devices that are well suited for environmental sensing sorts of applications. This was also my first dive into the world of Bluetooth Low Energy, which has been an interesting journey. There's actually quite a few specifications, many of which define services that are for environmental sensing. So there were some existing ways to integrate the data generated by these devices in forms that would be understood by Bluetooth applications generally. So my current plans, as I mentioned, those earlier Arduinos are small. Small comes at a cost, usually lower features. Well, comes at a low cost, but you don't get as many possibilities with them. So usually they can only perform as a Bluetooth low energy peripheral. So I was interested in building these devices out so they could talk to each other in an otherwise unnetworked space. So I've shifted the Pi towards serving as essentially a central hub for a star-shaped network for now, and using not the original Raspberry Pi 3, the full Pi, but the new Pi 0W is quite a bit smaller, can fit into more interactive enclosures and so on. So using the Pi as the central hub of that star network and having surrounding Arduino devices transmit over Bluetooth to those that Pi device, which would then gather all the data and push it up somewhere for some sort of cloud storage or sharing. All right. in my last 10 seconds, here's the full paper as promised, which has lots of links to the different devices we used, as well as the code we ended up writing for that. And if you want to talk Raspberry Pi or microcontrollers, I'm currently banned from bringing them up in the office, so I would love to discuss them with any of you. Thank you.
So next up, we have Airing Our Dirty Laundry, Digital Preservation Gaps and How We're Fixing Them by Naomi Duché and John Martin.
So we were bad citizens and we didn't put our slides on it. So John's going to do that while I start talking. And I'm going to give him the URL in case he doesn't have it handy. So we're from Stanford University. We've been working on addressing some of our preservation gaps. We have approximately 1.5 million digital objects in our repository, and that's about 247 terabytes of data, 233 million files, if I'm not mistaken. This is all in the slides. The slides are uploaded and available. All references are there, so don't worry about what you might be missing. The first thing I want to talk to you about is our format for how we preserve our digital content. We have a locally grown format called the Moab design. It was designed by Richard Anderson, who is a former Stanford employee. He's retired now. He put a paper up in the I've forgotten which journal, one of our journals. I think it was the
Code4Lib wiki.
Okay, about 4 years ago, and the main things about the Moab versioning is it is lossless. It's designed to be a sort of archival version in that you never change old data. It's always there. The versions are very clear. Someday I'll have my slide to help me remember. Don't let this happen to you. It also is, it keeps track of checksums so you can look at stuff later. Let's see, what else can I tell you about the Moab? I had some pretty pictures.
It's a differential versioning format, so only changed content results in new content.
That's right. It minimizes duplicate storage. He did some really nice research. It has some similarities to the bag structure, if any of you know that. But he also looked at how Git does things and a variety of other things. It's very well thought out. So that's awesome, and we love that. But the next slide that I'm not looking at is about our preservation gaps, and those gaps are include such things as once we write the Moab out to our storage, we never really check it again. It just goes, and we're like, yep, it's there. We're so happy. Here we go. Yay, thanks, John. So wouldn't want you to miss my cat. So here's the actual stats of our digital repository. Right, here's what I was going to say about this. The files have integrity in our Moabs. There's efficient single file retrieval. You can reconstruct the full object for any version. The metadata is human and machine readable, and it's optimized for storage and data transfer not having the repeated content. But it's also not compressed in any way, which is good for no loss, but kind of not good for data transfer. Our Moabs are created when we deposit things into our digital repository or when we update things that are already in there. And I call this my Cthulhu diagram. It's basically just showing you that we have NFS-mounted drives that we talk to, but the drives are separate from the preservation code that currently exists. So here's the slide I was just talking about, which is what we aren't doing. We don't know if there's bit rot. We don't know if there's transfer errors. If we have bad data that creeps in, it will eventually go onto our tape backup. So bad data perpetrates. and we back it up that way. And TSM is now kind of expensive in today's world, and we kind of just do the cross your fingers on the recovery. So Max, the Moab here, is looking a little worried, and he's wondering if his files are organized. And this is a little directory tree here on the right, but I have a little blow up, so it's a little easier to see. So the directory is named for the object ID, and then you have this version directory, which follows a canonical naming system, and then there's a data directory that has your files, your images, your PDFs, whatever is in your thing. And then there's a metadata part of that, and then there's also manifests, which keep information about the other files. So the first thing we did for our preservation gaps was we created a suite of integrity checks. So we check that the directory name with ID matches the IDs in the files. We check that the version directories are using the right format. We check what's inside everything to make sure it looks good. All of that code is open source and available in the Moab versioning gem. So Max was like really glad for this, but he's still worried. However, I will note that out of all of our objects that we have never checked, when we did this on all of them, we found one bad object, just one, and it wasn't actually bad because something had happened to it. It was like a human had gone in and added a directory. That was the only thing wrong with it. So we're okay. We have a good integrity of the code that's writing these things out. But we still have all these other problems of like not knowing exactly what's stored where, so on and so forth. So we came up with this idea of a preservation catalog, which would be a distinct data store that tracks which drive the Moabs are on and their latest version, and it will enable some audit checks. So the preservation catalog, because we're a Ruby on Rails shop, is a Ruby on Rails application, which also can mount the same drives. And one of the checks that it does is for every disk mounted with NFS, it will look for every Moab on that disk and check that it's in the preservation catalog and that the version, the latest version of the Moab matches what the catalog thinks is the latest version. So that makes Max feel good because somebody knows where each Moab is. The next check is, given a catalog entry, we look and make sure that the Moab is where we think it is and that the version matches. And that's important because that tells us when an object has disappeared. So those are great things, but we still need to know about bit rot and transfer errors. So unsurprisingly, the Moab has some manifest files that store checksums. So this is details you don't need to remember, but there's this manifest inventory that has checksums that you should be able to see in this blowout. And then the signature catalog has checksums as well. And we have a check that will go through for each version and check that all of the manifest files are correct, and then another check that will go through all of the data files. That will help us find any bit rot kind of stuff. Now onto the parts that we haven't done yet.
This is, I think, was originally intended to be like a 3 to 6 month work cycle, is turning into more like 6 to 9 months. So this is the part that we haven't gotten to, and I'll talk a little bit about sort of what we're not sure is going to make the cut, our prioritization. So the large area of functionality that's still left to be done is replication, archiving, and recovery, getting ourselves off of the tape backup system. And so just a few quick definitions. We have this idea of online copies, which are the exploded directory trees, the Moabs, that Naomi just described. We will also ship off archival copies to other endpoints so that we have duplicates. What we're calling an endpoint is something like either our local NFS mounts, our local-ish NFS mounts right now that store exploded Moabs, but our first pass for for archives will be cloud storage with AWS, but eventually we would like more geographic and vendor diversity both, and so we're looking at Google Cloud, Oracle Cloud, an in-house Ceph cluster, that sort of thing. Max is a little bit worried about all his eggs being in one basket right now. The three kind of main areas of functionality are replication, archiving, and recovery. So replication, the logic for that is which endpoints should have archival copies. And then since replication is asynchronous, we're not just going to ship off like 2 gigs or 2 terabytes of data every time a version is updated. Which endpoints still need that copy, that archive copy. We are hoping to implement preservation policies where specific objects can be told to go to different endpoints. So say like a larger object, giant video files or giant data sets, might go to an endpoint that's just going to put it off in Glacier or something like that. Something more cost effective. And the replication service uses the archive service to talk to those endpoints. So you can see that they're kind of lumped into one area of functionality in this diagram. I'll get to that in a second. And our simple replication strategy is that if we're going to archive something to an endpoint, we're just going to put all of the versions of that on an endpoint. An archive copy, since it's a single version subdirectory from the Moab, we could tar that up or some other just sort of single file thing. I think that's what we're considering right now. And we can put that version on the endpoint. This gains us 2 things. The first is that we're not shipping off the entire Moab every time again, even if we've only changed like a metadata stream, so that saves us some space. And because we're doing it with each version, we're not shipping off a new entire Moab every time and overwriting the old one, so we actually get proper archives, which we're not getting right now. Bad data will eventually get back up to tape. And so this means that we're not deleting any of our archival copies or intentionally changing any of our archival copies once they're shipped off. So the archive service, as you can see from this diagram, the intent is that it essentially acts as an adapter pattern for the replication service to talk to the cloud endpoints that it wants to route Moabs to. Eventually, we're not sure that that this will make the cut for this current work cycle. We'd like to audit our replicated archive objects. I think our current thought for the strategy for that is to randomly pull copies out of the archives and just spot check them for fixity. Also, I guess in terms of thinking about work, the structure and what we have time for, we've thought that even though they are kind of different areas of logic, we may implement archiving and replication as kind of a single code base, or maybe classes within our current preservation catalog code base, so long as that doesn't paint us into a corner in the future or make extending them harder. And also there are some things that it's not entirely clear which side that falls on, like ongoing integrity checking of archives, or making sure that an archive copy that was routed to an endpoint actually made it to that endpoint. And then the recovery service. So let's say that something goes bad, bit rot in our online preservation copy, or data gets maliciously deleted. As a first pass, we are okay with manual recovery. Our audit checks will be running regularly and will alert the service managers in charge of preservation. And so if we notice a bad copy, we can retrieve it. We can retrieve a good copy from an archive endpoint and reconstitute the version of the Moab that we care about, or just fix an entire Moab if it's like the online copy or something like that. Eventually we'd like something that's more self-healing that does that automatically, at least in the cases where the logic is just mechanical to do that. Another thing that we're not exactly sure what it'll look like yet, but object provenance. We want to be able to track the history of the object so that we can authenticate its life cycle, where it came from, what damage might have occurred to it. For now, I think that will be pulling from logs, but eventually I think we would like a provenance database. And then finally, we will likely be storing so we will checksum archives, sort of sped over that in an earlier slide, but we'll generate checksums for the archive files that we ship off so that we can do the fixity checking later. And we would like to store those checksums in a safe place. And there is an ISO standard for a trustworthy digital repository, which has some strictures for where checksums are allowed to be stored for this sort of thing, and we would like to live up to that eventually, but as a first pass, the checksums may live with the preservation catalog. You can see our references are linked in the second to last slide. If you have any questions, or comments or interest or pushback, we'd love to talk to you. Myself or Naomi or Sarav. Another team member who is also at Code4Lib but who just joined is Joe. The other two developers listed are not here this week. And that's it. If you have questions, come talk to us.
You know how I said to hold questions to the end? I lied. There's no time. So you can find all of these people and talk to them. A third coffee station has been added to the lobby level near the breakout sessions. I want to thank all of the people who made that happen. You're very awesome. If you have signed up to do a lightning talk this afternoon, as soon as I'm done here, you need to come up here and put your slides on the laptop. And please, if you have slides, make sure you check out the speaker FAQ on the conference website for accessibility guidelines. And now I am going to announce the breakout session topics. By the way, we have a 5-minute break on the way to our breakout sessions. So those of you who are kind of heading up a breakout session, you know, people are going to straggle in, so be prepared. First, oh, they have it on a slide. Oh my goodness. So yes, Ex Libris and open source discovery in the private dining room, which is the back right corner of Roberts. Data warehousing. Do I need to read these? Does anybody need me to read these out loud? Okay. Data warehousing and privacy is in the council room. Expanding the code of conduct GitHub repo to the Code4Lib community space and social guidelines is in the Senate room. The Fedora test API work, forum room. Teaching beginners how to be better at it. We're going to do that in Congressional B. I promise I won't yell. Poor man's VDI with LTSB and Drupal in the ballroom. Lib DevOps in Congressional A. Archive space core committers and community development in the cabinet room. Data for Lib, Spark in the Dark, working with big data in the executive room. ETD submittal and Vireo 4 interest group and users in the ballroom. Folio in the ballroom, and swords, real actual swords in the ballroom. So go forth and have a break.
One thing, can you clarify when we're starting again?
Yes, we are starting at 5. Well, I'm going to start announcing things at, what did we do here? 5 minutes to 4. And then we're going to get into the lightning talks. They go really fast, and as a courtesy to everyone who has to do a lightning talk, we want to make sure we're here on time so that they can have their full 5 minutes.
The reason I'm pointing that out is the announcements on the webpage is not correct. So we're starting with announcements at 5 minutes to 4?
5 minutes to 4.
Very good, thank you.
Thank you. Oh, have coffee.
Kevin. Going once. Okay. Nick. Ugh. These people will learn from this, you know? Santi.
Okay, what was this? A list of all the people who aren't here?
You. Oh, you're here. Okay, yay. Just one more. Oops. David. David Kennedy. Nope. Scott. Do we have a Scott? Oh my gosh. Dennis or Denis. Oh, hey. Okay. More giveaways later.
And we want to thank our giveaway sponsors, Oxygen, Rosenfeld, JetBrains, and GitHub. Thank you. So before we get into the lightning talks, and if you're giving one, you might want to kind of line up over there. We'll go there. In Quaker circles, I work in a Quaker library, we have the concept of an eldering, which is when a senior member talks to someone who needs some moral counseling. So someone brought to my attention that I should not have used the reference to a spirit animal this morning, and I would like to say yes, you are right, and I thank you for bringing it to my attention. That is a sacred concept in some cultures, and I should not have appropriated it for my joke, so thank you for speaking up. And I apologize, and I will remove it from my slides. I am sorry for offending you. All right, so we are going to get started with our lightning talks, and first up is Josh Wiseman. 5 minutes.
Hello. I got my slides here. Can you bring up the slides?
Gentleman who handles the technology. We have a problem. Presentation slide.
Okay, good afternoon. My name is Josh Wiseman. I'm from Ex Libris, and I handle the open platform and developer evangelism there. So I want to spend a few minutes today professing my love for standards. Very sexy. So, Valentine's Day, why not? So if we talk about what interoperability is the ability for different systems, software systems, technology systems, to work together, to exchange information, to send data back and forth to each other, And we know we can do that via APIs. We know that in Ex Libris Alma, for example, we have 160 REST APIs. We get about 3.5 million API calls every day from customers around the world, and that's great. But if you're using APIs, it means you're doing custom development, which is also great, and I'm in favor of custom development. But we should also love standards, and I'll take a minute to state the obvious. We love standards because they can increase interoperability between systems. They encourage the exchange of data, reduction of duplication. Data can live in one system and can be accessed by others. And it enables integrations without custom code, so we don't need to have all of that development. Maybe a bit less obvious, though, is as a vendor, why do we love standards? So we love standards because they enable leveraging existing libraries, application tools. They make integrations easier between apps. They reduce the development of one-off features, so we can integrate with several other systems just by implementing one standard. And they allow a bigger return on investment. Like I said, we can invest in supporting one standard, and we can get interoperability with many other systems for the same cost. So if you look at the alphabet soup of standards, we all know them, we love them, some more, some less. And in the ideal world of standards, right, you can just turn on two systems, configure two screens, and everything works together, okay? SIP2 is old, but it works. You can set up a self-check machine. You can have it work with any ILS in the world because of SIP2, because of standards. We love standards. Some standards are a little bit less specific. That great cartoon from this morning where it showed we can have 15 standards instead of 14, sure. But when standards are well established and they're well supported, then they can make integrations even easier. So if we implement one standard, we all of a sudden get interoperability with a whole bunch of different systems. So I'm going to show you a few slides of things that we've implemented in Alma over the past a couple of months, going back the year and a half. We implemented support for IIIF, and now all of a sudden you can use IIIF supported viewers like Universal Viewer to access any of your content, digital content, which is stored in Alma. So that's great. This is the Universal Viewer. It's not our viewer, but you can access your content in Alma because of the IIIF standard. SWORD for digital deposits. You can build a digital deposit tool. You can use standard SWORD libraries, Java, Ruby, and you can build your own tool because the SWORD server sitting in Alma can accept your requests. SRU, ISO hold. So we've implemented support for the ISO hold standard for SRU, and now for resource sharing systems, which query availability based on this standard, they can get access out of Alma. BibFrame. So for now from Alma, we've implemented a migration or a crosswalk to BibFrame, and now any of your MARC records, which are stored in Alma, can be accessed, harvested, or accessed via URIs in BibFrame and be harvested by any system which supports it, which expects it. So just a few takeaways then. So check what standards that your vendor software supports, okay? Recommend increased support for standards where it might help solve a problem. So if you're in communication with your vendor, say, hey, can you support this standard? Then we can use all these tools that interoperate with it. And encourage your vendors not to reinvent the wheel. And don't reinvent or don't invent new APIs or new ways of doing things where an existing standard might suffice. And if you are an Ex Libris customer, then you can go to this URL here, developers.exlibrasgroup.com/standards, and there is a list of all the standards supported by all of our products, and you can take a look and see what's there and make recommendations for things that are missing. Thank you.
Up next, we have Laura Rubel.
Thanks. Hi, I'd like to share with you a tool that I think has a lot of potential for building web apps with library collections, not just by those of us in the room here, but by lots of people who want to do creative things with libraries and archives. So Glitch is a web-based tool for creating, deploying, and hosting web apps. It's a product of Fog Creek, Anil Dash's company. They also did Trello and Stack Overflow. And the tool has a very friendly vibe, a very sort of playful aspect to it. This is the homepage there, you can see. And in Glitch, you can start a project. You get a template project to build a website. You can build a Node app or build a new website. So I recently built my first Node app using Glitch. And you can see here what the in-browser screen editor looks like. It has a way that you can see the code there, and I started with code that already existed and built my first project there. This is a data visualization project that I did with Library of Congress digital collections. So you select a collection from Library of Congress, and then once you select it, you get a visualization of color palettes extracted from different images in that collection. I did my data analysis outside of Glitch, but then loaded the files into its assets folder to be served up as part of the visualization. But I think the real power of Glitch is the remix aspect of it. There are lots of projects on there that anybody can repurpose as a starting point for their own collection. Some of you may know Tim Sherratt, who's a digital humanist in Australia, and he's built a lot of projects with the Trove digital library in Australia, including this project called Headline Roulette. It's a little game, and I remixed it into a photo roulette game based on Library of Congress collections. So it randomly selects a photo from the digital collections, chosen randomly via the API, and you guess the year of it and try to see if you can figure out where in that picture was taken. These are some of the features in Glitch. In particular, it has a really great script editor with syntax highlighting, and it auto-updates your your website for you as you're working. But there's also console if you like that. And although things are remixable and can be reused by others, your API keys stay private in a .env folder, and there's also a place to keep some of your data private as well. Although everything I've talked about is free, it is a commercial platform, so you always want to make sure you have an exit strategy. You can export your projects to GitHub, or you can download them. You could download them and then sort of put it up on your own web hosting if you didn't want to stick with Glitch, for example. And you can even delete your project if you want to. So I think Glitch has lots of potential for libraries. I had a lot of ideas working with it about how we could create starter kits for working with library APIs. It's a great place to do some prototyping, and then you could take it out of Glitch and use it elsewhere. I think it'd be a great way to sort of start up a hackathon, like give people a place to start with in creating apps in a hackathon rather than having to totally start from scratch. You could build community around your APIs and some of your digital collections that way. And I think in general it's great as a learning and experimenting platform that has a low barrier to entry. You don't have to install anything on your computer. Everything's done in the browser. These are all the projects that are available, for example, just based on Trove, the Australian Digital Library. So wouldn't that be great if something like this page on Glitch, existed for Library of Congress, or your library, or your consortium, or other group of libraries? I wanted to end just giving a quick shout out to the Library of Congress Labs, with whom I've been spending 3 months of research leave, where I got to do some of these kinds of projects and experimentation, and they're trying to put their digital collections and APIs out there in a way for a lot of people to repurpose them and remix them. And also the data artist Jer Thorpe, from whom I first learned about Glitch, and who's also doing a lot of cool things with library collections on that platform. So go out and have fun and remix. Thank you.
Next up is Steve Mayer.
Sorry, you gotta find the right Chrome instance.
It's actually on the screen to the side.
I can't see which tab is mine on that. Yep, that's the one I want. There we go. Okay, my name is Steve Meyer. I work for the University of Wisconsin-Madison, and I want to talk about how we are experimenting with linked data to enhance a library discovery interface. So first of all, this is not about a linked data project like BibFrame, where we're talking about a wholesale conversion of catalog data into linked data. This is actually more about being a consumer of data. And at this URL, we've got a description of kind of the philosophy behind this particular experiment. Here are a couple of URLs where you can see some examples of how this works. I'll show you one in just a moment. It's basically our production catalog. We have a special URL with -LD after the word search that causes the linked data functionality to happen. So here's one of our examples. If I go to this record, I can see that we've got our normal bibliographic data. Down here at the bottom, I can see that I've gone out and fetched some information to build some small knowledge cards about some of the identities that are in this, that are related to this work. So some of the kinds of data that we get to see is basic descriptions, abstracts from DBpedia and Getty. There's some interesting information that libraries don't themselves curate that we can pull, but which we think might be relevant to researchers, such as what's the alma maters for a particular person. There are also some interesting pieces of information like notable works, which is a data point that, while it's very interesting, we don't necessarily know the provenance on it, who's actually making such an assertion, but nonetheless, it's something that we can say, okay, we can create some links, see if we have those in our collections, and then we can do things like, what's that influence network that was actually referenced in one of the earlier presentations. So how do we do this? Well, we've got a lot of systems that are involved. In a lightning talk, I don't want to go through all of them, but you can sort of come back and see the slides. At a high level, we're basically doing this identity crawl where we're coordinating between our catalog, going back to ALMA and its linked data APIs, trying to resolve the VOF URI, which then acts as an identity hub. And this is one of the things that's really actually kind of harder than it would seem to do, which is in my catalog, might be holding onto a URI for a Library of Congress name authority file URI. But what I ultimately need to get to is my endpoints are things like the DBpedia or the Getty URIs, where they have the extra information that I don't yet know about. So trying to find information, trying to resolve those is actually a pretty tricky programming task. Once we sort of solve that, we ultimately get to these kinds of triple statements. This entity in VOF is the same as this thing in DBpedia, for example. Then we sort of repeat the process over and over again for all of the different entities that we might want to do. One of the things that we encountered is trying to decide, do you crawl for this data or do you query for it using Sparkle? And in this case, we landed on Sparkle because we're working sort of in a real time. It's heavily cached, but it's still, the first time you hit it, it's still a real-time query. And we found that using a Sparkle query, we could actually pull more data back together as a cluster of assertions than if we had to sort of do this individually. So for example, a highly influential person, according to DBpedia, might require us to make 54 HTTP requests. And as you can imagine, while a patron is just sort of loading and their attention is a little bit scarce, we don't necessarily know whether or not we can get that, we sort of have that level of time. So we've got the code here. It's not great code, but we share it to sort of open a conversation about it. We've even got a demo. It's a Ruby gem. We've got a demo app for how you would use this in a small Rails app. That's the second link down there. The core responsibilities of this code are just to fetch data and cache it. We have this concept of a small graph that's from multiple different sources that we can use to instantiate one of these knowledge cards. We're instantiating objects using an object relational mapper kind of system for RDF called Spira. That allows us to work with view code. It looks very much like Rails model objects. And I'm out of time, so if you have any interest in learning more about this, please feel free to contact me. Thanks.
Next up is Maggie Hughes.
Hi, I'm Maggie Hughes, and I'm the Collections Data Archivist in UCLA's Library Special Collections. I'm going to talk about a project I worked on with two colleagues, Shira Peltzman, who's Special Collections Digital Archivist, and Joseph Oriana, who's a Technical Documentation and Service Desk Specialist in our library's IT department. Shira, Joseph, and I have been developing a strategy for managing and tracking archive-specific workflows using Jira's ticketing system. As I'm sure most of you know, Jira is issue tracking software. UCLA Library's IT department was already heavily using Jira for their help desk and bug tracking. We were expanding its use to special collections where it was not used, except to interact with IT. I'll continue to refer to Jira specifically, although much of what I say will likely apply to most issue tracking software. My slides are online if you'd like to take a closer look at the screenshots. There are a number of challenges when managing archival material and its associated data, thus having a reliable system to manage workflows is crucial. In our department, some of our challenges were opaque workflows. These could be undefined, implied, or undocumented. Passive communication, we lacked feedback loops when edits or additional work was needed, or the ability to report back on progress, and a multitude of siloed information locations like email, old access databases, and others. Our goals for implementing and adapting Jira's ticketing system in special collections were to aggregate project information, enable workflow tracking, improve reporting and feedback, and increase transparency. We identified two workflows to start with: born digital processing and peer review of finding aids and MARC records. Creating issue types in Jira allows you to customize tickets for different workflows. Here are screenshots of two issue type tickets: born digital processing and peer review of a finding aid and MARC record. We made an effort to share terminology among issue types and mirror our department's language whenever possible. For each issue type, we created a customized workflow, a set of statuses and transitions that an issue moves through during its life cycle and is representative of our department's processes. Here's a screenshot of a peer review workflow that involves passing the ticket to multiple colleagues. It allows tickets to be put on hold, requires some steps, and allows others to be skipped when appropriate. The workflow for born digital processing is more straightforward. However, the ticket will move through statuses without much variance. However, the tasks and processes are lengthier and more complex. In order to reflect this, we employed checkboxes within the ticket in combination with a streamlined workflow. As tickets move through their workflows, Jira sends automatic email notifications when a person is added to a ticket, when the ticket is reassigned, and when a person is tagged in a comment. The commenting section allows people involved with the ticket to communicate easier and to the benefit of others. We created dashboards in Jira for issue types with some basic graphs and charts. Shown is a chart of created versus resolved tickets for peer review and quick statistics on the status of any open tickets. Of greater impact for us is Jira's ability to embed reports in Confluence, a wiki in which the library does much of its internal documentation. Here's a report for all in-progress tickets. This allows anyone in the department to easily see an update on workflows in the same place where the documentation for that workflow lives. And this is a report for all closed tickets. The reports are customizable and allowed us to select fields based on what will be most relevant to our users. We created a Library Special Collections Jira project, which is the home for all of our issue types and allows for new issue types to be added in the future, all grouped under our project umbrella. And all tickets have a field at the bottom that will allow us to link related tickets together. We plan on using this to link tickets that concern the same collections. Our implementation of Jira is flexible and extensible. In addition to adding traditional archives workflows such as accessioning, there's a lot of potential for us to use Jira ticketing when communicating with other departments, such as sending materials that need AV digitization to our library's conservation department. We've been using our new peer review workflow for almost 6 months, and through use have received helpful feedback and adjusted some fields. In the upcoming year, we hope to begin using the born digital processing workflow, build out new workflows, and take advantage of the linked issues feature. It's had a positive impact on the department, significantly improving workflow transparency and communication. I hope these examples are helpful to anyone else who might see the potential to leverage Jira's flexibility to manage workflows outside of an IT context. Thank you very much, and please reach out if you have any questions.
Next up, we have Kate Dybel.
So hello, everyone. For those of you who don't know me, the fact that I'm about to give a talk about accessibility should be of no surprise. After all, if it's Code4Lib, Kate's talking about accessibility. But those of you who don't know me or haven't heard the news, since October 2007, I am now at Syracuse University. I left the University of Washington. I am the inclusion and accessibility librarian there. Yes, I actually get to spend my time coordinating diversity and inclusion efforts throughout the SU libraries. It's an amazingly unique opportunity, and of course, I do a lot on dealing with library disability access. And I've learned a lot since then. Certain little things are such as, did you know that you should not trust the Braille on bathroom signs? Some of our women's restrooms are wrong. That's a little embarrassing. Adjustable height tables are great, but you should really not leave the power strips on the floor. It doesn't really help the people who need the adjustable height. But here's the big lesson I want to share. The EDUCAUSE IT Accessibility Constituent Group. So EDUCAUSE is one of those many academic institution groups out there, deals a lot with academic service. This accessibility constituent group formed to gather information, to advocate, and even work with vendors to improve the accessibility of any IT involved in higher ed. That's the URL for it. These slides are up on the repo already. And there's even a mailing list that's pretty active. And it formed to meet a couple of things. Make accessibility important, more visible, and that's actually been something happening there too. There's been a huge increase in accessibility lawsuits. So unfortunately, the stick is finally winning in regards to getting people to actually do things about accessibility. But the expertise is also thinly distributed. Many of you can think of the accessibility expert at your school or library. And it's one institution that's not going to change the vendor. So this is great, but it's university IT people. Library IT is very different. I mean, we do deal with software licenses, but when I've been talking with these university IT people, they don't get that we have this larger emphasis on content licenses and content providers. Our vendor market is far more limited. It's like, I've honestly been told, can't you find an alternative to ProQuest? A little try there. And just the sheer number of licenses, we're usually at 2 orders of magnitude higher than anything other IT departments deal with. So, and moreover, there's more than just university libraries. We need to consider the public libraries. We need a library accessibility community. And there are some great efforts out there. Elsevier has a great team that reaches out, talk to me about them. The Big Ten Academic Alliance has shared some reviews. There's the Library Voluntary Product Accessibility Template repo. But we need more. We need to support all library types. We need to share more broadly IT accessibility reviews. We need to share best practices for our digital and physical spaces. We need to do more community education. We need to learn more from our patrons with disabilities. We need to work en masse to help make vendors be more accessible. One school's not going to do it. One consortia's not going to do it. But if we do coordinated efforts, we can get those vendors to change, even if it's just filing the same bug report repeatedly. And we really should just keep doing more and more, and just any experiences we have, even if it's weird questions of like how to deal with an Office of Civil Rights accessibility complaint, which I have heard many of us are going through right now. I might suggest a drinking night for all of us in that. But it's also, there are some interesting questions like, what if your repo needs to be remediated? And I've been talking about doing something like this for over a year. I even talked about it last year. But now my job actually lists as a duty that I can be working on building communities for this purpose. I can't do it alone though. So tomorrow I'm going to be having running a breakout on building a library accessibility community. If you're interested in being an advocate, if you're an expert, if you want to learn, or if you just have any reason, please join me. We'll be discussing first steps and directions to take. Some of you have already begun talking with me, and this is great. At my accessibility workshops yesterday, people were interested in forming such organizations. We're going to make this happen. Please join me. We can change the world, and those of you who know me, I'm rather stubborn and will get my way if I have to, even if people get hurt. which just means more people with disabilities. I win. Thank you.
Next up is Patrick Murray John.
Oh, that's right. I don't have any slides. I didn't plan something, but I've been to enough unconferences where lightning talks are a standard thing that when I see that flip chart that's a sign up for lightning talks, it's like, ooh, I better do this. So here I am. Not really a presentation per se, and not so much a question, not even a comment, but a celebration. So I'm Patrick Murray John. I work on a funny web publishing tool called Omeka at the Roy Rosenzweig Center for History and New Media. How many of you have used or are familiar with Omeka? Okay, that's what we would like to see. So the celebration is this month, Omeka turns 10 years old. And that is because of everybody who just raised your hands, using it, asking about it, asking for features, playing with it, teaching with it, creating with it. So this is sort of my chance to say thank you to all of you who have used Omeka and created and contributed with it. As some of you know, Omeka has sort of taken off in crazy directions that we never anticipated. It's been picked up and used by the DPLA and Europeana, and the tons and tons of undergrad and graduate level courses in history and library science. When the Grateful Dead took all of their stuff and gave it to UC Santa Cruz and said, do something with this, UC Santa Cruz used Omeka and created some wonderful plugins to put that content online. I've always been a bit bitter that they didn't need some on-site consulting from me, but I'll be strong. I want to also say that in those 10 years, we have learned a lot, again, thanks to all of you, and that has sort of culminated in the recently released Omeka S, which is a complete rewrite of Omeka. Many of the same principles, but incorporating lots of the lessons that we've learned. So if you haven't tried it out, haven't heard about it, please come find me sometime. Especially for this crowd, Omeka S, I hope will be very interesting because it finally gets at that multi-site capability. So instead of people that you work for asking you to spin up an Omeka site, and then another Omeka site, and then another one, and another one. No, finally, we're thinking of you, and one installation, many sites. It also brings in a lot of features for compatibility with other systems, so we're trying to make it easier to talk to Fedora 4 and DSpace. We hope that these are the sorts of things that will make your lives easier and that will help Omeka S keep going on for another 10 years. Thanks very much.
And next up, we have Maddie Schrader.
Hi, I'm Maddie Schrader. I actually don't have slides either. My talk is called Working with Mark, an Outsider's Perspective. Like I said, I'm Maddie Schrader. I wrote a open source Mark editing suite called C# Mark Editor, and I wrote it not knowing anything about libraries or Mark records or bibliography records or anything similar, pretty much from the ground up. I've always been a self-learner, so the first thing I did was Google what is a Mark record. And a couple sources came up that were extremely useful. The first was the Library of Congress Mark 21 documentation. The second was the Working with Mark Wikipedia page, or wiki page for Code4Lib, which was phenomenal. And lastly, my coworkers had a giant book about AACR2 that was probably about this thick, and I think I read 3 or 4 pages of it. It was a little daunting. But the first thing I found out was that Mark records there wasn't a way to work with Mark records in my chosen programming language, which is C#. So the first thing I did was figure out how to read a Mark record, which thankfully Code4Lib helped me with that. All of the linked class libraries gave me something to base my code on and work from there. And once I was able to read a single record in and write a single record out, I started getting into batch editing. And that was an interesting experiment, because the first thing I would do is read all the records in, do work on them, and then write them all back out. And that was great until I found out Mark record files are 700 megabytes or bigger. For example, the entire Library of Congress catalog is 9 gigabytes of raw Mark. So I ran out of memory really quickly. So I learned a new approach, which was open the file for reading, read a single record in, work on it, write a single record out, which was probably the thing I should have done to begin with, but you don't think about these kind of things all the time. And I did that for a long time, and I figured out there's got to be a better way to work with this format, because it was a thing I was doing all the time for my work. And what I ended up doing is I built a relational database in SQLite. And I wrote a script that would read in the Mark record, convert it to a relational database, and write it back out again when you're done working on it. So you could do everything in SQL, which was had a lot of benefits. First, it was read once and write once, so you don't have to think about doing everything in little pieces. You could test reading everything in and reproduce that, and test writing everything out and reproduce that, and didn't have to think about a lot of stuff. And you didn't have to rewrite all of my batch editing code each time I went to a new project or a new script I had to figure out. I didn't have to copy and paste anything. I didn't have to open up any libraries. I just opened up my tool, built the database, wrote some SQL, and exported it back out. It does have some downsides, though. It's much slower to set up the first time, so it's not great for one-off projects to do development this way. And it does require a lot more hard drive space. That 9 gigabyte Library of Congress catalog I was working with ended up being 26 gigabytes once it was in an SQLite database. But even then, SQLite surprisingly handled it without too much of a headache. So from there, that's kind of what is a good thing to figure out. I've been hearing all these great things about OpenRefine, but somebody told me today that not even that can handle any kind of huge amount of data. So there's always something new to learn and a new way of doing things. And as an outsider to the community, when I first came into the library industry, it was interesting to kind of take those steps from a unique perspective. Thank you very much.
Next up is Andrew Nagy.
Hi, everybody. I work with a company called EBSCO. A few of you may have heard of them. One of the initiatives that I've been working on is to help spearhead and enhance some of the community development around the Folio Project and helping to grow that community. And I was able to convince some of the higher-ups at the organization to set aside some money to help spearhead some seed funding. And so I just want to talk to you very quickly about a new grant that we actually launched it last year. And I believe my colleague Christopher Spalding mentioned this at last year's Code4Lib. So I just wanted to bring it up again. We have a grant called the Innovation Challenge. So you heard about, if you don't know what Folio is already, you heard about it from Peter Murray about an hour or two ago. But the Innovation Challenge is a grant that we set aside $100,000 to give back to the community to help foster and grow this open source project. So if you have an idea, if you have a challenge to solve, and you're looking for some seed funding or some help financially, we encourage you to apply to our grant. The deadline is coming up March 2nd, so very short period of time away. But it's an opportunity for you to help fund an idea that you have in terms of solving an innovative challenge. So the idea is that we expect you to produce the results as open source. So any work that is done as a result of the innovation grant is given back to the community on GitHub as open source. It's expected to also follow along with the Folio API set. So it has to be something that is integrated with and takes advantage of the Folio community. But unfortunately, we no longer have $100,000 left because thankfully we've already funded 2 projects. And so we're now down to $75,000 that is left remaining. So the next deadline, again, is March 2nd. So if you're thinking about contributing, I encourage you to put together a proposal. And I also want to footnote by saying if you are at an institution where you don't have development resources, but you have an idea, you have a vision, you have a problem that you're trying to solve, I encourage you to apply as well. We, in the community, have found developers that want to be a part of the project but don't have anything necessarily driving them to work on. So we can help match developers with institutions that want to solve some of these problems. So far, we've funded Villanova University. They're integrating ViewFind as a front-end tool to sit on top of the Folio project, and also the University of Illinois, UIUC, to bring an existing project that they have onto the Folio platform. Their Hoot waiting list service and their equipment loan form to help circulate laptops and tablets, whatnot, in more of an automated fashion on the Folio platform. So as I mentioned, it's something that has to be innovative. It's something that has to be built on the Folio platform. But the Folio platform is fairly agnostic. So we're not really forcing you to solve specific problems, but we invite you to think about solving some simple problems or some hard problems, but think about it in an innovative way. I don't think I did this presentation in Europe, so I don't think there's a huge problem about what countries are eligible for funding, because I imagine most of you are from the US. But last but not least, deadline, as I said, March 2nd is the next one. There might be another deadline after that, but I encourage you to think about the March 2nd deadline. And if you have any questions about whether or not you have an idea or what you might bring together, or if you're looking for collaborative help with another institution, email us at this email address, and all of the information that you need about this grant is on that website, which all of a sudden the screen just went away. But if you just Google Folio Innovation Grant, you'll get right to it. So if you have any questions, foliogrant@ebsco.com, and that goes to myself and some of my colleagues, and we're happy to answer any questions that you might have. And I'm giving you a minute back of your time. Thank you.
Next, we have Kelly Fitzpatrick.
All right, that's working. So I'm Kelly Fitzpatrick. I work at the Berkman Klein Center for Internet and Society up in Cambridge, Massachusetts. And today I'm going to share Tag Team, an open source tagging and aggregation platform developed by the Harvard Open Access Project at the Berkman Klein Center for Internet and Society at Harvard University. And my notes in this presentation are derived from some earlier presentations at a MozFest Fringe event and DPLA Fest earlier this year. Tag Team's functionality is built around social tagging, and it gives users the ability to create tag vocabularies and manage tagging projects working in groups, but also independently. This gives the ability to scale projects to include more collaborators over time and give them permissions that match their roles on the project. All Tag Team projects are open by design, giving the public an opportunity to learn more about other projects that they might not be involved with already, take a look at their tag vocabularies, and give creators the chance to find new collaborators. When we tag resources online, we create informal tag vocabularies that are usually known as folksonomies. Folksonomies give us control over the organization and discoverability of content online, but can present obstacles at the point in a project where it might benefit from a controlled vocabulary. As these tag vocabularies associated with a project are developed over time, Tag Team can move a folksonomy into a controlled tag vocabulary, giving projects more control and flexibility over how their information is presented, organized, navigated, and help standardize some of the metadata associated with their projects. So to achieve this, tag changes can be created at the item level or across an entire project, using filters to add new tags, omit tags no longer in use, or edit existing tags. So let's say you're working on a project to tag online resources related to medieval art and hedgehogs as they appear in it. Let's say you've applied the tag hedgehog to maybe 400 items in your tag team project, and you want to make a change to create a plural tag, so hedgehogs from the singular hedgehog. You can create a filter to make that change retroactively and moving forward, so you don't really need to make any item level changes or change any of the item level data, which definitely saves a lot of time. So as a platform, Tag Team offers flexibility in format, which can provide more options in how information can be represented. For each tag or tagger on a project, Tag Team creates a feed with a unique URL, which is available in formats which include RSS, Atom, and JSON. What this does is this allows users to share and subscribe to specific feeds and export feeds in these formats. Second, as a platform, each Tag Team project supports full Boolean search functionality. And as you create each search, that search will create a unique URL, so you can save that search for the future or share that query with some of your collaborators or folks you just might want to share a project with. So Harvard University hosts an instance of Tag Team, which is available to support academic projects, but as a platform, it really isn't just limited to that. As an open source platform, users and developers are free to launch their own instances of Tag Team using code made available on our GitHub repo for use outside the context of academic projects. So for a quick use case, the Open Access Tracking Project has used Tag Team since around 2012 to tag and aggregate over 65,000 objects, searchable resources related to open access as part of the Harvard Open Access Project. Just checked that number earlier today, up to just over around 67,000, so that number is growing. And operating as a crowd-based project, users can browse and search items by tag or keyword within Tag Team platform across topics and subtopics, and then share those feeds with their collaborators or keep them for reference online. So just to close and give an idea of what we're working on, what we're looking at in the future is Tag Team was initially launched in 2012, and since then we've been working on building on existing functionality and adding some fun new features. We're currently working on developing our next major version update, which will include new features and upgrades, which include automated feedback on tag changes for use on group and crowd-based projects within the platform, which definitely helps communication across teams. And looking forward, we really hope to see Tag Team incorporate into open research projects to become part of that open workflow as a tool for users looking to tag and aggregate information and enrich it with meaningful metadata at the project level, as well as brainstorm applications across different disciplines and use environments. And at the stage, feedback is also really awesome. So just to close, Tag Team is supported by the Laura and John Arnold Foundation as part of the Harvard Open Access Project at the Berkman Klein Center for Internet and Society. And since lightning talks are short, if you want to chat more, find me after the talk. See you around. Thanks.
Next is Mark Matienzo.
What's up, y'all? How's it going? You feeling good? Tired? Nah, I can't be tired. Oh, goodness. Chrome. I cannot see this window. Sorry. I'm having a little bit of trouble. We'll try this again. Oh, there we go. I'm just trying to figure out how to switch tabs. Sorry. I feel very inept. This is why we don't do this stuff live. There's an increased chance for embarrassment. It's okay. I'm doing just fine. There we go. We'll edit this in post. It's all good. All right. All right. You doing well? You feeling good? All right. So how many of you like karaoke? All right. How many of you like possums? All right. You'll see why that's important later. So I'm going to talk a little bit about what I see as an allied community to Code4Lib called the indie web community. And I want to start by talking a little bit specifically on, I've been working on my website for quite some time. And throughout the last maybe 3 or 4 years, I've really been focusing on trying to identify what the right sort of simple tools that I use to manage my site. So I use Jekyll, which some of you might know is a static site generator. And over time, I've wanted to add a lot of sort of cool features to my site that manage the content, that allow me to manage my content in the way that I need to. I want to add more structure to my data and do all these really cool things that allow my site to be able to share content across platforms. So for me, I felt this as a specific point of tension between simplicity and complexity. So how do I manage my content using simple tools but that do what I need? Do I make a conscious choice to use social media platforms or publishing platforms where I might be giving up rights to my own content? Or do I end up managing a growing cluster of complicated tools or CMSs to fully own my content? So about 2 years ago, I found out about the indie web community, which aims to provide a people-focused web. The community, like Code4Lib, is really self-organizing, active in IRC, and holds in-person events to bring people who build websites closer together. Why is indie web a movement? In their own words, our online content and identities are becoming more important and sometimes even more critical to our lives. Neither are secure in the hands of random ephemeral startups or big silos. We should be holders of our online presence. What do y'all think about that? Yeah? All right. So let's talk a little bit about principles. So I'm not going to go through all of these. If you go to the IndieWeb website, you'll see these in a little bit more detail, but I want to touch on a few, as I think some of them really align with Code4Lib. What's most important is how we think about owning our own content or data on the contemporary web and how we lose that publication through on silos. I also think it's important to acknowledge the fact that we need to address our own needs first, but we also want to share what we do. We might not always be able to use each other's tools easily, but we have an opportunity to learn from one another through sharing documentation or even presenting and having conversations. We should also be building for longevity, ensuring our data and content is future-friendly and future-proof, and work towards a plurality of projects and technical ecosystems. Finally, we should have fun. We should remember how fun getting our first websites were online and when we first shipped our first code. So while IndieWeb is not just about the technology, a lot of important work has gone on within this community to come up with patterns or specifications that allow us to interoperate. We also know that we need to get our content to work across silos or with silos as well, and the IndieWeb community has really come up with a lot of great opportunities to make that possible. Again, I'm not really going to explain these, but I'd be happy to talk to you about any of this stuff. There's also an important note that we seem to know in this community that technology is complicated because of social factors. This is both a strength of the IndieWeb community and the Code4Lib community, but is also something that's a major struggle. Sometimes these challenges end up creating pretty severe rifts in our communities, though. There's a tension between the indie web view of the world and some of the views subscribed to the linked data community, for example. And in particular, Amy Gee and Christopher Leber-Weber acknowledge this in recent blog posts of theirs, specifically because they both participated in the W3C Social Web Working Group, and acknowledge that the art of consensus around social web stacks is really quite difficult. Ultimately, two communities that found themselves at some technical odds made some really significant progress, and I'm happy to talk to you more about that too. So in thinking about how to move forward, I encourage you to plug into the indie web community, think about what we in Code4Lib might learn from them and what they might be able to learn from us. Join or start a local indie web meetup like the Homebrew Website Club, host your own website with its own domain, and think about other opportunities for us to pull together. In particular, I think there's a great opportunity for us to think about how we build out a federated constellation of personal sites and the tools, specs, and so forth that drive interoperable content and data and inform work on things like web archiving. So I can't wait to see what we come up together, and thanks. I have stickers, and sign up for karaoke tonight. There's 3 spots left. Thanks.
Next up, we have Francis Kaiua.
Multimutia. I'm Jambo. Oh, I was just going through the languages as I learned them. How y'all doing? If I can get this thing to work. Is it Control Tab or is it Alt Tab? Oh, there you go. Thank you. My name is Francis Kaiua. I've been Code4Lib for 11 years. This is my first time speaking ever. Please clap. I have spent the last 2 years as a DevOps, whatever DevOps is, for a project called Documenting the Now. And in the 2 years we've spent with our team, is Burgess still here? No? Think about social media. And in the past 2 years, the only thing that has come up is, I gotta get off Twitter. No, I'm serious. Do you guys hate Nazis? This is not a trick question. Would you like to be on a site that actually bans Nazis? There's your answer. I've set up a Mastodon instance for Code4Lib. It will have a code of conduct. And all I'm asking is for a bunch of people to help me to ban the Nazis, to give us a community that will not be like Twitter. We'll have a steady timeline. Your tweets will go in order. Your tweets will not be sold. We'll delete that stuff if you want to be forgotten. And I'm asking for people to join and help me make that happen. I don't get any money for it. There's not going to be advertising, but people can talk. And isn't that a cool thing? Talk to me this week.
And we have Elizabeth Wicks.
Hello, humans. Let's see. Desktop. Use desktop. There. It's still not desktop. There. Okay. So, I have a technical reference question. Am I in the right room for that? I hope so. So my name is Elizabeth Wicks. I'm a faculty member at the School of Information Sciences at Illinois, so formerly GISLIS. I teach the foundational programming course. I'm one of the people who teaches the foundational programming course. My students are mostly LIS students. We do have an information management program as well. Of the LIS students, the majority are from humanities, so we're talking history, art, English, literature, etc. Some, like myself when I was in the program, are from social science. And I get about, in my class at least, I get about 1 to 3 people a semester who have something like a STEM degree. I don't entirely like that label, but there we are. So I inherited the class 2 years ago as an adjunct on an emergency basis and sort of got them delivered materials and delivered students with 2 weeks to go. And it was very much a, we're gonna make this work semester. So I didn't have a whole lot of control, but I was like, this has been used for a long time, so I have full faith in this. And I started doing it, and I looked at this book, and the book was Python Programming and Context, which is not a terrible book in itself. Chapter 2 is called Python. Pi, like the irrational number, Python. It is a chapter introducing for loops. This book is it is designed and written for beginners to programming. Not like, oh, you know something and now you want to learn Python, but no, like theoretically freshman year introduction to programming. Chapter freaking 2 is trying to teach you for loops with trigonometry. Let me back up and remind myself. I came from the middle ground, social science, so I took stats classes. I did math. I'm fine with math. I didn't take a trigonometry class outside of high school because I did stats. I didn't have to do calculus. Now, a lot of programming books presume that you dig math because, for obvious reasons. But chapter 2, so let's run down the implications of this being in chapter 2. Week 1, hey, how you doing? Here's a syllabus, we're cool, right? Trust in me, we're gonna be fine, you're gonna be fine, we're all gonna do this together. Week 2, what's a variable? What's a script? Let's just get literally anything to run on your computers, please. Also, maybe let's stop using idle. Week 3, trigonometry. Are you ready? Are you ready? So imagine trying to learn both what a for loop is and also wait, what? I mean, I get a triangle, right? I'm fine with that. I'm an adult. But, So some are totally fine with this. They were like, whatever. Give me my computer, I'll type this stuff in. This is cool. Others were super not. And I would get these emails, these are like literature students, right, from undergrad. Beautifully written, just agonizingly horrendous emails. I copy and pasted them into Word. 1,000 words on how they feel emotionally crushed, multiple times. Multiple students. So, I kind of need to fix this, right? My favorite screenshot from Netflix. So, what the heck happened? This is a screenshot from our lovely library catalog. Thank you, developers, for making this exist. These are 3 books from the 1970s in our high-density storage. Each one of these books has the word programming and at least a STEM word from library or librarians or libraries in the name. In the name. Books go. So my reference question is, where the heck are they? Where can I get a programming textbook, not an O'Reilly book, let's be clear, a textbook on introduction to programming, not Python, but programming for a beginner level that isn't like math is awesome sauce, right? So not math is math oriented. It can have, you gotta do numbers, right? It's fine. But not trigonometry, let's be clear, there's a line. So not math oriented, uses real Python, so the GooseDL book is amazing, but it's not entirely, is that GooseDL? Or that one? Okay. So my ask here is, I want a real book that is a real textbook that won't destroy my students with math. There's my Twitter. Please tweet me. My time's up. Thank you so much. Have a great night.
All right, it is time for the daily wrap-up. I want to give a thank you to the program committee, Aaron Collier, Jamie Mears, Bo-Yun Kim, Chris Beer, Carrie Gordon, Matt Sherman, Peggy Greisinger, Julia Kim, and Cynthia Ng. If you see them tonight, they do not pay for their own food or drinks. Everybody, all right, amazing. There are 2 events tonight. Game night starts at 7 p.m. at the boardroom in DuPont Circle. Feel free to bring your own games, and there will be unlimited access to their game library as well. LibTech Women is also having a happy hour here in the hotel in the Marquee Lounge from 6 to 8 p.m. If you have any questions, please contact Bo-Yun Kim at Bo-Yun Kim in Twitter, Slack, or IRC. Don't forget to set your alarms tonight. We start promptly at 9 a.m. Have a good night.